For our DMA10, we already have covered sections 2 and 3. Today we are going to begin with section 4, and we will be talking about integers. And then we will get into computation with integers. Integers are numbers that we have on a number line. When we look at integers, we're going to be looking at both positive and negative integers. Integers will be represented as whole numbers, not fractions, not decimals. We're going to talk about fractions, mixed numbers, and decimals when we're in module DMA20. But for right now, we are going to be looking at whole numbers. In the middle of a number line, you would have your 0. That's like your central beginning point. As you go to the right on a number line, we would have 1, 2, 3, 4. As we go to the right, the numbers that we have get larger. The number line is like a mirror image of each other. So when we go to the left of 0, we're going to have -1, -2, -3, -4. As we go left, our numbers are going to be getting smaller, okay? We will do some comparisons of numbers using greater than, less than, greater than and equal to, less than and equal to. So we're going to have a conversation about those things as well. If I wanted to do, and let's do a simple comparison here, obviously we know that positive numbers are going to be bigger than negative numbers. So if I were to give you, let's say, a 4 and a -4, and we were going to compare those two numbers, which one of those would be larger? The larger one is the positive number. And when we have an inequality symbol written, it would be open to the bigger number. The point goes toward the smaller number. So this symbol here would be the greater than symbol. If I were to have, let's say, 3, so if we're comparing both positive numbers, let's say we're going to compare the numbers 3 and 4, both being positive. Here's 3, here's 4. 4 is further to the right on the number line, so it's the larger value. If I were to read this, this would be 3 is less than 4, okay? So I'm going to go -4 is here. It's smaller than the +4. And in this problem, the 3 is also smaller than the 4. And when you write the symbols, it's open to the bigger number. The point goes to the smaller number. If we're comparing two negative numbers, let's look at what happens with two negative numbers. If we have -3 and we're comparing it to -1. Initially, when people see these, you're thinking positive, going, oh, 3 is bigger. But on the number line, notice the -3 is here, the -1 is here. So when you have negative numbers, if the value that is closest to the 0 is the bigger value, the number that's further away from the 0 is the smaller value. So the -3 is smaller than the -1. The value, the digit 1 for the -1 is bigger than the -3. So let me jot these down. This symbol is your equals, meaning two items are the same. If you have an equals with a line through it, that's going to be is not equal to. This would be greater than. If you have the greater than with a line underneath, that would be greater than or equal to. This is our less than, and this would be our less than or equal to. Another thing I want to put on this page in our notes is that if you are graphing something, you are either going to use an open circle or a solid circle. So if we are doing something that is equal to something, that would be noted with a solid dot. Is not equal to, we're not going to use, there's no dot we would use for that. If we're graphing a greater than, when you're graphing something with greater than, it is not equal to, it is just greater. So we would use an open circle on the graph. A greater than or equal to would be a solid dot. A less than without the equals would be an open circle. The less than or equal to would have a solid dot. So what I'm going to do here is I'm going to give us a graph, and we are going to label that particular graph, okay? And I know mine aren't drawn to scale, but that's okay. All right, so if I were to have, let's say that we want to graph that x is less than -1. That means I'm going to come to -1. I'm going to put an open circle. If x is smaller than -1, my arrow would go to the left. If I wanted to graph that x is greater than 0, I would come to the, let's say greater than or equal to 0. So I would come to the 0. The 0 would get a solid dot because it's equal to, meaning it includes it. Bigger is to the right, so then my line would be coming in this direction. If I wanted to graph something between 2 points, or actually we're not going to be graphing between 2 points, so we will probably be okay on that. But let's say that, well, we can go ahead and do one. Let's say we have an x that's going to be greater than or equal to -3, but it's going to be less than +2. So if I were to graph this and x falls between those 2 points, x, I'm going to go to my -3, and since I have the equals, I would use a solid dot at this location. It's smaller than 2, but not equal to it, so I would go to the 2, I would have an open circle, and then I would shade what is in between our 2 dots, between the open and the solid. So that's how you would go about graphing using open or closed circles and which direction to shade. Another thing to keep in mind is if you're looking at, you would use vocabulary, so for something being positive or negative. If you lose something, if you have a loss, well, actually, let me make 2 columns for this. Let's write the terms negative and positive. And as I give you a term, we'll determine which column it will go under. So if you have something and it talks about a loss, you lose money, that would be a negative. If something increases, that would be a positive. If you had a temperature that fell so many degrees, or if you have something that talks about a decrease, that would be a negative. If you make a deposit in your checking account, that's going to be a positive. If you make a withdrawal or you write a check, that's going to be a negative. If you go upstairs, if you walk upstairs, that would be a positive. If you go down something, that would be a negative. So you will have a couple of things that'll ask you whether a number would be a positive or a negative, and you're going to use the wording, the terminology, to determine if it goes up or if it goes down. Oh, here's another one. If we mention that something is above or if something is below, that would be some other terms that we would use. There is a special word called the absolute value. The absolute value of numbers absolute value is the distance a number is from zero. The way we know absolute value is by using two parallel lines on each side of the number. Absolute value is never negative. It's always a positive because we're talking about the distance of something. So if I were to ask you, what's the absolute value of -7? These two lines are the lines that represent absolute value. That means how far is this number from zero? It is 7 places. If I asked you about the absolute value of 103, 103 would be 103 places away from zero. If I asked you what's the absolute value of 19, 19 would be 19 places from zero. What's the absolute value of a -74? It would be 74 places from zero. So absolute value is never negative. It's wanting to know what distance the number is from zero. Another term is the word opposite. Opposite numbers are the same distance from zero. One is positive, the other is negative. So if I give you a number and then I ask you what is the opposite, that would be such as if I give you a 5, what's the opposite of 5? -5. If I give you a -34 and ask you what's the opposite of -34, that would be a +34. So opposites are the opposite of positive or negative of the given number. Let me give you a couple of examples here that I want to be sure we're familiar with. And let's see. So if we were to have okay. This means what is the absolute value of -14? That's the distance from zero. So that would be 14 places from zero. What is the absolute value of +4? Well, it is 4 places from zero. Now for this one, there's a sign in front of the absolute value symbol. First, we simplify the absolute value of 8. That would be an 8. But since there is a sign here, This is asking you what is the opposite of the absolute value of the 8. So the answer for this is 8, but the opposite of that would be the negative 8. For this one, this means what is the opposite, and this is a parenthesis, not absolute value. What is the opposite of a negative 3? That would be a positive 3. Let's now look at adding integers. Adding integers is adding positive and negative whole numbers. When we add integers, you have examples in your book that you can look at with the number line. Sometimes I feel like people get a little more confused when they are looking at the illustrations of those. So let's talk about what happens when we are going to add numbers, okay? So when we're adding integers, if we have the same sign, if same sign, what you're going to do is you're going to add the absolute values and keep the sign. So let me give you an example. If we have 4 plus 2, we're going to add 4 and 2. That gives us 6. If I'm going to add negative 10 plus negative 3, they're both negative numbers. They have the same sign. I'm going to add 10 and 3. That gives me 13. I'm going to keep the original sign they had, so that would be a negative 13. Let me also show you on your calculator how to use this. Well, 4 plus 2, pretty simple. Now, for the second one, negative 10 plus negative 3. I'm going to show you a wrong way first. If I hit the minus as being the negative for 10 minus 3, plus, and let's say I use that same sign again for negative 3, I'm going to get all kinds of stuff coming up. So if you get a syntax error, that simply means you hit the signs in a wrong way, okay? Also notice, you see you had ANS that popped up before the 10? Even though it looks like negative 10 plus negative 3, I didn't use my symbols correct. If you will look beside the decimal, do you see this minus that's in a parenthesis? This represents negative. So what I'm going to do is, this is my negative sign, negative 10, plus, again, come back down here, negative 3. That gives me negative 13. Let me also show you. Do you see the difference in height? This was the negative, this is the minus. So there's a difference in the height of those. So if you have the same sign, you add the absolute values and you keep the given sign. Now, if you have different signs, if different signs, you're going to find the difference, which means to subtract, and then you're going to use the sign of the one with the larger absolute value. So if we do these longhand, and let's say I have 8 plus -3. Now, when we handwrite problems and we are adding, and if the second number is a negative, you're often going to find, and actually I should have wrote it on this one and I didn't, put a parenthesis around, because a moment ago, remember on the computer we can't do the plus and the minus side by side. So when you're handwriting, you're going to find that you would put a parenthesis around the second one. So if we found the difference in these numbers is 5, and the larger absolute value belongs to the 8, that's a positive number. If I were to have, let's say, -12 plus 2, one's positive, one's negative. The difference in those two numbers would be 10. The absolute value of the -12 is larger. That happens to be a negative number, so my answer is a -10. Now, when you type these in on the calculator, we're going to do here 8 plus, this is your -3. If you were to type 8 plus and you use the minus accidentally, you're going to get that syntax error we talked about a minute ago. The first couple times you're using the calculator, you're going to accidentally do that. So that's why I'm showing you mistakes, so that when you get that mistake, you'll know what you were doing incorrect on that. The second one we had was -12. Wait a minute. -12 plus 2. And it gives us our answer, -10. Remember, if I accidentally tried to use the minus sign in front, it pops up with ANS. So if it leads off with that, then you would know that would be incorrect. It's not going to give you the correct answer. Another thing that we want to look at is some of the properties of integers. Properties of integers, we have what's called the commutative property. And you will find a chart of all of these in your book on page 1-29. The commutative property, and this applies to addition and multiplication. So with the commutative property, you can add in any order. This applies to addition and to multiplication. You can use any order. So for example, you could take A and B and add them, or you could put it in the order B plus A. In other words, 1 plus 2 is 3, and 2 plus 1 is still going to give you 3. Whichever order you use it in, you're going to get the same solution. If you said 2 times 5, you said 5 times 2, 2 times 5 is 10, 5 times 2 is 10. So it means you can rearrange the order. The associative property, and this again is of addition and multiplication, means that you can shift the parentheses. You can change your grouping and still have the same answer. So in other words, if I had A plus B plus C, if I were to group the first two, I'm going to get the same answer as if I group the second two. So for example, if I group 1 and 2, and here I group 2 and 3, 1 and 2, that's going to give me 3. 3 plus 3 is 6. Here, 2 plus 3 is 5. 5 plus 1 still gives me 6. The same thing applies to multiplication. Whichever order, let's see, if we have, let me fix that. If we have A, B, and C, I can group either my first two or I can group my last two. So again, let's do 1, 2, and 3. If we're multiplying these, 1 times 2 is 2, 2 times 3 is 6. 2 times 3 is 6, 6 times 1 is 6. The last two properties we have are the additive identity and multiplicative identity. The additive identity. The additive identity would be if you have a value and you add 0 to it, you're still going to get the same number. So if I had 25 and I add 0 to it, my answer is still going to be 25. We have the multiplicative identity. The multiplicative identity is that if you have a value and you multiply it by 1, you're going to get the same value. So if you had 83 and we multiplied it times 1, we're still going to get a solution of 83. And for section 6, we're going to look at here subtracting integers. When we subtract integers, what we're going to do is we're really not going to subtract at all. We're really going to add integers we're going to change our subtractions to addition, and once we do that, we're going to still follow those rules of addition. So for example, if I were given, let's say, we are going to, let's write it down this way. We're going to rewrite subtraction as addition, and we're going to follow those rules that we had, follow the rules of addition. So if we were to have, let's say, 10 minus 3, if I rewrote it as addition, it would be 10 plus the opposite of, this is a 3, the opposite of 3 would be negative 3. We find the difference in the two numbers, it's a 7. This is the bigger absolute value, so it's a positive 7. And this is how we're used to subtracting anyway, just 10 minus 3. The problem is going to come when we have a negative. What if I had 10 minus negative 3? When I rewrite it as addition, I have 10. I change this to plus. The opposite of a negative 3 is a positive 3. And 10 plus 3, they're the same sign. I add them, and they keep the same sign that they have. Let's do another. Let's say we have negative 8 minus 2. That's going to be negative 8. I'm going to change the subtraction to addition. The opposite of a 2 would be a negative 2. These have the same sign. I combine them, 8 and 2 is 10, and keep that sign. But if I had negative 8 minus negative 2, the 8 stays the same, change. And a lot of people, you would hear the term keep, change, change. So that's technically what you're doing. You may have heard that in times past. The negative 2 becomes a positive 2. They have different signs. You find the difference, which is 6. The larger absolute value is for the negative 8, so that would be a negative 6. All right, so this is longhand how to go about doing the subtraction of integers. However, what I want you to do is when you're checking your work, I want you to do it and type it on the calculator exactly as you see it. So On the calculator here, we're going to have 10 minus 3 is 7. 10 minus negative 3 on the calculator, you would do 10 minus, this is your negative, negative 3, 13. It does the operation for you. Negative 8 minus 2. The first one we key in with a negative sign, negative 8, and then it is minus 2, which is the negative 10. The last one was negative 8 minus negative 2. So negative 8 minus negative 2 is going to give us a negative 6. And actually, I think we have time. I can go ahead and touch on section 7. Section 7 is multiplying and dividing. The rules are going to be the same for multiplication and division of integers. When we multiply and when we divide, if you have the same sign, your answer is positive. If you have different signs, the answer is negative. Okay, so let me write this out for you. In other words, if you are going to multiply two positive numbers, if both signs are the same, your answer is positive. If you're going to multiply two negative numbers, your answer is positive. Same with division. If you divide two positive numbers, your answer is positive. If you divide two negative numbers, your answer is positive. Okay? So if you have the same sign, your answer is always positive. If you multiply a positive and a negative, or if the negative's first and the positive second, this positive, one's negative, your answer is going to be negative. If you divide a positive and a negative, it's negative. If the negative were on top and the positive on the bottom, guess what? It's still going to be a negative. So let's do a couple of examples of these. If I were to give you, and let's say we have 2 times 3, that's going to give us 6. If I give you negative 4 times negative 8, negative times negative is a positive, that gives us a positive 32. If we have, let's say, we have 20 divided by 4, that's going to give us a 5. If we have negative 16 divided by negative 8, that's going to give us a positive 2. Same sign, your answer is positive. If you have negative 5 times positive 3, you're going to have a negative 15. If you have a positive 10 times a negative 4, you're going to have a negative 40. A negative 8 divided by a positive 2 is going to give you a negative 4. And if you were to have a negative 12 divided by a positive 4, your answer is going to be a negative 3.